As I mentioned, I'm presenting this for Drew. This is a very important project that affects the entire city in the way we actually pick up trash. One of the things that is mentioned here, that the city of Tyler has rated the waste department as being one of the best top performing or best considered departments throughout the city of Tyler itself. And I'm not going to go into detail on some of these, but I will give you a few minutes to just look, or a few seconds to kind of just look at the rankings that the city, the waste department was able to achieve through Tyler 21 rankings. One of the things that we looked at when we first initially started this project was to look at how many calls are actually being received into the waste department. And by what we mean calls is the amount of calls in regards to what the complaints are, whether it be missed trash or just different concerns that the customers have. In this case, what we ended up looking at was that we're pretty much averaging about 90 call-ins overall into the city in regards to solid waste issues. And this just gives you an idea of the time series plot of this particular project, and you can see how it spikes up at different times of the year. For example, in July, it really spiked up, and maybe that's a little bit of the 4th of July holiday, but also at that point in time, if I recall correctly, there was a pilot that was going on during that time frame that helped spike up the amount of call-ins that were being received at the waste department. One of the things that we looked at, and when we go through these processes, sometimes we decide, okay, this is too large of a scope of a project, so we want to scope it down and identify which are the actual issues within the overall calls. So what we identified was the garbage misses was actually representing 60% of the total calls that were coming in. From that, we asked ourselves, okay, what areas are they coming in from? Where areas are the calls coming in from predominantly? Well, in this case, the north side of town was actually calling more significantly into the city. From there, we actually broke it down into the actual different routes that are actually getting the most call-ins. Now, when we did our project, when we finally decided which project we're going to look at, which route we're going to look at, we identified Route 11. And the reason we didn't go for Route 6, 14, and 17, those were the routes that were actually identified as having additional pilot runs on that particular project, or in those particular routes, I'm sorry. So we said, okay, those may be skewed, have some skewed data, so we went with the next best one that didn't have any issues with it or any other additional items with it. So we went with Route 11. From that, we identified that they're actually receiving on a monthly basis almost 4 calls on average with the standard deviation of 2, so they can range up between maximum of 8 calls down to 1 call in any given month. Here's just a run chart to check the stability of the process and to check the stability of are we getting mass call-ins at one particular month, or is it pretty much steady across the entire year? In this case, you can see it's pretty steady, and you can identify that by the p-values located down below. Project charter, as you've seen, many of the projects that we have all have project charters, and that's really just to define what the project is so that we have a determined problem statement and also our project goals. This project, what we calculate just for this particular route, that's not including when we leverage out the project to the other routes. This is just this particular route. We're estimating the potential savings, if we can get up to 90% reduction in calls that are being received, to about $1,700. Again, this is just for this particular route. Once we leverage it out to all 18 routes, potential savings can be a lot more. When we look at it from a capability analysis standpoint, we looked at it from a perspective that we have 785 units. That's 785 houses that are on this particular route. Of that, we have 80 opportunities, and what we did is say, okay, because they get picked up twice a week, we included the 80 times. In other words, 80 times over the course of the 52 weeks, and 34 defects that are being identified. So overall, the route itself was doing pretty good. I mean, typical industry standard, and when I say industry standard, I'm using a very broad brush to do that. But typically what you end up seeing is a process normally will work around 3 standard deviations. I'm sorry, not 3 standard deviations, at a 3 sigma level. And ultimately we want to increase that sigma level to higher number, to 6 ultimately being the goal. Okay, these are just our goals and how we define them. This is the process map that was created with the team at the solid waste department. And this is basically trying to understand how the call-in process works, as well as the whole process of having to go back out and pick up that trash that was missed. These are the fishbone diagram. Fishbone diagram is used to identify all the inputs that contribute to the failures, contribute to the defects. And the YX diagram is used to highlight which factors or which inputs we're going to address first, because ultimately, if you can see, we have a lot of inputs in here, and if we just start out with one or two, we may be working on the wrong one. So what we do is take a ranking based on our experience, based on information, based on data, and give them a certain ranking so that we know where to start. We also did a time study. We did various cycles time studies out on the route, and what we identified was that based on the cycle time, we only need one truck to run this route. And the truck has the capability at this point in time to complete and pick up all the trash on that specific route. And here's just some more information. This just breaks it down even further for you. The set outs, you can see very clearly we're way below tag time, and the pack outs are a little bit different. But overall, when you look at it, the end result being that one of the concerns that we had was that we didn't have enough time to pick up all the trash, and so that the operator was actually rushing through and missing trash as he was going through the route. Well, what we identified was really he has enough time to do this. And this is just looking at different scenarios. We looked at holiday pickup volume. One of the concerns was that when we have holiday volume when the holiday volume picks up, that we have more calls coming in, and what we found was that statistically there is no significant difference in change from that. We also looked at the routes themselves. Each truck out there has a route system capability, or the air track system, I'm sorry. And what we looked at was, well, how are they completing the route? What are the routes are they taking? Are they going from one end of the location to the other location? And what we ended up finding here is that, and we broke this up into 3 areas, or four to five areas. And what we found was that the driver would start in one area, crisscross across to the other area, and then come back to the other area, and was doing a lot of crisscrossing, a lot of mileage that was going on there. Ultimately, we figured that that is not efficient enough to get the system to pick up the trash in a timely manner. Another thing that we identified was corner houses, and this is actually one of the major areas when we go to actually implement AirTrack using the AirTrack system itself. Why? Because the corner houses, like we see here in this example we have here, these houses are on the corner, and the areas that are located in blue that you see here, in the system that we have, it says, and it tells AirTrack that that is where they should be putting their trash cans. So what ends up happening as the route goes through there and the system tells them this is the route you're supposed to follow, which in the arrows, they go up and down this road but never pick up the trash, because these corner houses will put their trash on their driveways that are actually on the side. Okay? And that's one of the reasons why some of the trash was always being missed, because one, the system itself takes the truck down a entirely different route. Another issue that we identified was border issues, because each area is divided into sections, and what we found was that in each section there's potential of border or route border issues. For example, in this case, we have a duplex that's located up there. Well, in this case, Route 11 would be picking up the trash from that duplex, but they were actually assigned to Route 2. Another area down here at the bottom where clearly Route 11 is assigned the houses that are right there clustered, Route 2 was assigned to pick them up, and the houses are right next to each other, so you'd have almost 2 trucks coming together to pick up houses that are right next to each other. So you have to watch that, and then there's other examples of that, of the corner or the border issues that you have to address. So once we adjusted that, it fixed some of the issues that we were having. Also, another thing that we need to really consider when we're using the route system is that Route Smart, does not take into consideration what are dead ends, unless you tell it it's a dead end. But for example, here, North Gaston actually comes into a dead end here and then continues down here at the bottom, but there's a dead end right there. It doesn't continue for whatever reason. I have no idea why they built the street that way. Well, the way the Route Smart was telling them was to go through that area. Another example would be over here on Lawler. On Lawler Street, it indicates that that's a street, but in reality, it's somebody's backyard. And the system was telling them, you have to drive down that backyard. Clearly, I mean, we weren't going to do that, but you have to address those issues so that, one, you can get the route to be efficiently programmed and outlined through the system. Another issue that we saw using Route Smart was that sometimes it doesn't take into consideration major thoroughways, major intersections. And here in this case, it was telling us to do a U-turn in an area that has a 4-lane highway. Okay, so ultimately we can't do a U-turn in that location. So we have to address that and change it in the system. Once we identified all those factors that we saw up there, we made the changes, we addressed them in a way that now the system itself is running much more efficiently. It has taken into account all the items that we just identified to you and is now routing the truck in a much more efficient manner. Okay, it now, example here, now it picks up the trash instead of just going down this one way. Granted, it's still sending the truck down this route for the other houses that are located next to the corner houses, but it's also adjusting it and picking up the side where they have the side driveways on the corner houses. It also adjusted the border confusion. Now we have clear defined areas that this is Route 11, that's Route 2, and it's adjusted the system to pick them up accordingly. And also, as I showed you earlier, is now the system also takes into account those dead ends and the non-existent streets. And it's also adjusted for the U-turns. Now it sends them in a different path, so it's much more efficient when they continue it. For example, this route here indicates they're returning back from the landfill and going back into the area that they left. And then when they come down, they're already starting in the new area down at the bottom. Another thing that Route Smart actually allows you to do, which I think is very powerful in allowing more control to the supervisor in that area, is that one, we're able to give a street-by-street direction to the operator. Based on that, we can take an audit where the crew is at that any point in time. Why? Because you see here, there's also times down there at the very bottom. So if I wanted to go and audit a truck, I can look at it and say, okay, within the next 30 minutes, they should be on X street. I can go to that X street and they should be there within 5-10 minutes of that, passing that intersection or location that you're trying to audit them on. And it just gives you more control as to where they're at and how they're performing. Another thing that we utilized, this is just created, is this visual management board. In this visual management board, you'll have the different routes identified. You'll be communicating to them how many units they're supposed to pick up, what their actual time was from what is scheduled to be picked up to how long did they actually take, and then from there take corrective actions to help them improve that time frame. Next steps are basically to continue leveraging this project out to the additional routes. Right now, I believe, if I'm not mistaken, Route 13 and 15 and Route 11 on the south side have been completed, and now it's just to continue rolling it out to the additional routes throughout the city itself.